Hello everyone, welcome back to my channel. So today we are in neighborhood reactions. In that neighborhood reactions today, now I am going to explain about the one of the most important reactions, that is in apple reactions. Yes, apple reactions. I think you hear that Mistonube reactions as well as apple reactions, both reactions follow the same mechanism. But Mistonube reactions, we are using the reagent is Z plus ppH3. But coming to the apple reactions, here we are using carbon tetrabromide or carbon tetrachloride in the presence of ppH3. So dead plus ppH3 in Mistonube reactions, apple reactions, carbon tetrabromide or carbon tetrachloride and ppH3. And reactions mechanism, everything is same. If you see this apple reaction, so I am going to give the examples to you. So very simple, 100% inversion production will get, 100% inversion product will get. What is that inversion product, and then how we'll get that inversion production? So it's very simple. See here, so here also we'll take same above the side alcohols. Initially we are going to take the alcohol, so it is going to treated with one of the nucleophile. So in this nucleophile, it is going to attack on the SN2 pathway, right? It is in above the plane. Then how it is going to attack? Obviously it is going to attack in below the plane, right? So it is going to attack on the below the plane. This OH will leave, so chlorine will attack on the below the plane. This is for what? 100% inversion product. So what are the reagents we are using? Here CX4 and PPH3. X is nothing but chlorine or bromine. So very simple reactions. So you will get 100% inversion production. So what is the reaction mechanism? We'll see the reaction mechanism. So if you see the reaction mechanism of this apple reaction, see here, first chlorine, C, chlorine, chlorine, sorry, CCl4, right? So it is going to treated with PPH3. So in this PPH3, it is going to take the chlorine from here. This bond is migrated towards the here. So you will get PPH3 PPH3 containing a positive charge as well as C, Cl, Cl, Cl. Am I right? You will get negative charge. So if it is, there is a two chances. So minus chlorine. If it is going to leave one chlorine, then you can get carbon. This is the one possibility. Or if they are going to give any polar solvents, or if it is going to treat us with H plus, then you can get CHCCl3 chloroform. Am I right? Okay, this is secondary. So we'll get, this is the main. So if you see here, PPH3 and chlorine, here it is a positive charge. So it is going to treat it with the alcohols. Am I right? So oxygen containing a lone pair of electrons. This lone pair of electrons is migrated. See here, this PPH3, and this chlorine is going to leave. So minus chlorine, right? You will get RO PPH3, here H, oxygen containing a positive charge, right? It is a positive charge, highly unstable. So hydrogen is going to remove. This hydrogen is going to remove. So you will get, I will write here, PPH3 positive charge, right? So this, here we have a lone pair of electrons, right? This bond is migrated here. So it is acts as a best living group, right? It is acts as a best living group. So see here, again we have a one nucleophile is there, right? Chlorine minus. This chlorine is attack on the inversion SN2 pathway. This bond is going to leave. Finally you will get the product is RCl. This is for what? 100% inversion product. This is for what? Apple reactions. If you see the example, so that we can understand easily what is that exactly apple reaction. So I am going to give the examples to you so that you can understand what is that exactly happening here. So here you will take one example. This is the important example. right? It is a OBN, equatorial, OBN, equatorial, here OBN, here OBN, OH, here OAC. It is going to treated with CBr4 as well as PPH3, right? Again one more reaction, ET, it is above the plane ET and below the plane hydrogen, CH3, above the plane OH, below the plane H. It is going to give CBr4 PPH3. If you see this example, very simple examples, right? Very simple example. Here they are given a carbon tetrabromide, right? Carbon tetrabromide. Here giving the H, OH, alcohol. Alcohol, it is a equatorial positions, my dear friends. If you see carefully, if it is equatorial position, then bromine is attacked on the axial positions. If it is axial positions, bromine is attacked on the equatorial position simultaneously. So here bromine minus, right? This bromine minus is attack on the equatorial positions, then OH will leave. Then you can get the product is here. Yes, it is OBN, OBN, OBN. So here you will get bromine is axial position as well as remaining is same. This is for what your product, my dear friends. Very simple reactions. You can see here bromine minus. This bromine minus, it is OH is above the plane, right? OH is above the plane. Obviously, bromine is going to the attack and below the plane. Below the plane, then OH will leave. You will get the product is ET. C. It is a OH, H, CH3. So OH is above the plane, you will get the bromine is below the plane, and here H will go to the above the plane. This is for what your product. Very simple reactions, apple reactions. If they are going to give the alcohols in above the plane, just you can simply add the bromine or chlorine below the plane. If they are going to give the below the plane, just you can add the bromine or chlorine in above the plane. That is in reverse positions, reciprocal positions. This is called SN2 pathway reactions. I think very simple reactions. I hope you understand these reactions. Thanks for watching this video. Thank you so much, everyone.